We're in Unit 4, Block 1. We're starting example 3. In this example, it says that we're starting with a tank of water. At first, the tank is draining, then they plug the hole, and then they begin to fill the pool. The function r of t equals 5t minus 20 gives the rate at which the water is draining or filling in the pool. You plug in t minutes, and it outputs the volume increase or volume decrease rate in gallons per minute. Before we dive into answering the actual questions posed to us in the problem, let's look at the given function and the graph, and let's label a few points and make sure we're really clear on the meaning of these points in context. So, for example, the y-intercept of this graph would be 0, negative 20, and that would mean at 0 minutes, the tank is draining at a rate of 20 gallons per minute. The negative is indicating that the tank is draining. The volume is decreasing. Next, let's look at this x-intercept. It's at 4, 0. That would mean at 4 minutes, at exactly 4 minutes, the tank is neither draining nor filling. So that seems to be the instant when they plug the hole. And I'm also going to go ahead and look at 6. When you plug in 6 into the function, you'll have 5 times 6, which is 30, minus 20, so you'll get 10. So the point is 6, 10. Now this is positive 10, meaning the tank is filling at that time, where the tank is gaining 10 gallons per minute at that instant. So notice then when this rate function is below the x-axis, that indicates that the volume is decreasing because the rate is negative. So on this entire span down here, where this function is below the x-axis, the volume in the tank is decreasing. The tank is draining. Then again, at 4 minutes, they stop the drainage, they fill the hole, they plug the hole, and then after 4 minutes, the tank is filling. There is also an input-output table here to the right where we have some different minute amounts given, and we could plug the minute amounts into the rate function and identify the exact rate at that instant. So when t is 0, we get negative 20 gallons per minute. When you plug in t is 1, you get negative 15. Every time the minute increases by 1, the gallons per minute increases by 5 because it's linear, so we can just fill these in real quick. All right, there we are. Now let's go back and look at the questions that are being posed to us. It says, how much water did the pool lose while draining? So during this time span from 0 minutes to 4 minutes, how much water was lost in the pool? And then how much did it gain while filling if it stops at 6 minutes? And then we can figure out the overall change in the water. So what we are being asked about here is accumulated change. And this is what we were speaking about in our previous examples, accumulated change in our rate function. Now, in the previous problems, we were able to have a constant rate of change the entire time span. So it was just taking that constant rate times the time. But now the rate itself is changing. It's negative 20, and then it's negative 15, and then it's negative 10. So it's not the same rate of change over that entire 4-minute period of draining. But recall, what we said also was that we can think about finding this accumulated change by finding the area between the rate function and the x-axis. And remember, though, it's not just an area. The accumulated change also has sign to it. We know down here the volume in the tank is actually draining. The volume is decreasing. So this accumulated change is negative. We can find the area of this triangle, but we have to count that area negative when we think about it as accumulated change. So we just need to recall, how do you find the area of a triangle? Remember, that's just 1/2 base times height. But when we think about height, we're not just thinking about it as a length, which is always positive. The height is actually the height of the function. So 1/2, the base of this triangle spans from 0 over to 4, and the units on that are minutes, 4 minutes. That's the base. The height of this triangle spans from the x-axis down to a height of -20. So the height of the function is -20, and the units of that function are gallons per minute. Again, we notice when we multiply this together, the minutes in the numerator cancel with the minutes in the denominator. 1/2 times 4 is 2. 2 times -20. So we're going to get -40, and the units are gallons. Now, that is not saying that there are -40 gallons in a tank. Remember, this is giving us accumulated change in the tank during that time period. We're saying from minute 0 to minute 4, the tank lost a total of 40 gallons. All right, next it said find the amount of water that the tank gains after they plug the hole. So from minute 4 to minute 6. Again, we're going to use the same idea here. We need to find that area between the x-axis and the function, the rate function. So here's the x-axis. Here's the rate function. We're finding the area. I'll put it in green. We're finding the area of this little triangle. So the area there, again, is 1/2 base times height, since it's a triangle. This time, the base of the triangle spans from 4 minutes up to 6 minutes, so the base length is 2 minutes. The height of that triangle, it goes from the x-axis up to a height of 10, and that 10 is gallons per minute. Multiplying it out, 1/2 times 2 is 1, and 1 times 10 makes 10. The minute divided by minute cancels those minutes units out, and it's left in gallons. This time our answer came out positive, so our accumulated change is 10 gallons, meaning from minute 4 to minute 6, the tank gained 10 gallons total. So first the tank lost 40 gallons, then the tank gained 10 gallons. Overall, since it lost 40 and then gained 10, overall from minute 0 to minute 6, it lost 30 gallons. So this was all information we gathered from the rate function. We didn't actually have the volume function itself. But if you go to the next page, you will find that I have an example volume function given here. So here on the next page, example 3a, we have a volume function. V of t equals 5/2 t squared minus 20t plus 400. So notice in this function, we're plugging in t minutes, and it actually outputs the volume of water in that tank in gallons. So for example, in this function, 0, 400, it says at minute 0, there's 400 gallons in the tank. If you actually go over here to 4 and plug 4 into the given function, you're going to get V of 4 equals 360. Now notice what happened there. From minute 0 to minute 4, the gallons in the tank decreased 40 gallons. Went from 400 down to 360. If you go over to minute 6, and you plug 6 into the function, what you're going to find is that it is 370. That you get out. At minute 6, there's 370 gallons in the tank. So from minute 4 to minute 6, the tank gained 10 gallons. Why is this important? On the previous page, we looked at a rate example where from minute 0 to 4, it lost 40 gallons. From minute 4 to 6, it gained 10 gallons. That rate function was the rate of change of the volume. Notice this V of t function, if we were to go down here and find V prime, we start with 5/2 t squared. If you drop the 2 down, you'll have 5/2 times 2t. The 2's cancel, so you'll just have 5t. The derivative of minus 20t is just minus 20. Derivative of 400 is 0, so V prime of t is 5t minus 20. This function, this derivative of volume, is the rate function from the previous page. The derivative of this volume function is that original function we looked at on the previous page. We were able to take the derivative of this function and find out how much the volume went down, how much the volume went up, simply by finding these areas between the rate function and the x-axis. Again, these areas between the rate function and the x-axis, where you count area negative if it's below the x-axis, those are telling us how much the volume function itself went down or up. It's telling us about the accumulated change in the volume function on these different time periods.